I'm Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach for BTech 5th semester students, electronics branch, is digital communication. And the topic that I discuss today is introduction of probability and random variable. We start with the definition of probability. What is probability? Probability is a numerical index of the likelihood that a certain event will occur. It's a value between 0 and 1, which reveals the relative possibility that an event will occur. So this numerical index have a range from 0 to 1, depends upon likelihood that a certain event occurs. Okay. So a probability of 0, or you may say close to 0, implies that an event is very important to occur. Means if the probability is 0 or close to 0, indicates that that particular event or the particular event have a very bad or very poor chance to occur, or very least percentage of chance to occur. And the probability of 1 or close to 1 gives higher assurance that an event will occur. And if the probability is close to 1, this indicates that, or this gives you 100% assurance of the event to occur. So between these two extremes, 0 and 1, different values of probability are expressed as a decimal, such as 0.0, 0.20, 0.90, or 0.5. So probability may be 0.20, 0.90, or 0.5. This expressed in decimal. Sometimes it also expressed in fractions, such as 1 by 5, 9 by 10, or 1 by 2. Or note that both ways of expression can easily be expressed in percentage also, 20%, 90%, or 50%. So there are various ways to express probability, either in decimal or in fraction or in percentage. Now, to understand the probability, you should also know different terms used in probability, like what is experiment, what is outcome, what is event, what is sample space, right? So first, what is the experiment? Experiment, a pre-planned process for the sake of producing data that can reveal the purpose of the process, application, or meet the objectives of the study in which the experiment is conducted. Or, in other words, in the context of probability, when the term experiment is used, it typically indicates a process that can result in only one of several possible outcomes, right? So whatever you start a process in probability come in the category of experiment, right? Then what is outcome? Actually, in experiment, what you have to do? You have to do various trials to get the result, right? So to define outcome, what we say actually, the result of a single trial of an experiment is called outcome. So various trials of what you have to do in performing any experiment, you have perform a various trials to get the result. So the result of a single trial of an experiment is called outcomes. So we have various, where we have multiple trials means multiple outcomes, right? But if you want to define only what is outcome, it is the result of a single trial of an experiment. Then what is event? A collection of one or more outcomes of an experiment. So if you do multiple trials, then collection of these multiple trials means multiple outcomes, and the collection of these outcomes come in the category of event. So a collection of one or more outcomes of an experiment is called event. Then what is sample space? All possible outcomes taken together represent the sample space for that experiment, right? So sample space means when you perform a certain experiment, then you have performed several trials to get the outcome. So if you have a collection of total outcomes that possible in particular experiment, then these total or whole samples of a particular experiment is called as sample space. So sample space means it is the possible outcomes of an experiment, total possible outcomes, right? Then it becomes a sample space. Now we have various experiments, various outcomes, event and sample space. So for example, if you have an experiment of rolling a die once by playing a game which you called as a Ludo. So in Ludo you have a die, right? You have a die. So the possible outcomes of a die are 1, 2, 3, 4, 5, 6, right? And you define a even odd number. Means out of this 6 possible outcomes, what you want odd number. So odd number, to come odd number is an event. And what is sample space? All possible outcomes. And all possible outcomes are 1, 2, 3, 4, 5 or 6. Taking a test. If you perform a test for students, test number A, B, C, D or F, then your event may be passing the test. How many students pass the test? A, B, C, D, F. So sample space is A, B, C, D, F. Selecting an age. This is one of the experiments, selecting the age. Outcomes, old, middle or young. And what is event? Getting older. So the sample space is old, middle, young. Like birth, either male or female. Then event is gender choice. So sample space have only 2 possibilities, either male or female. Your experiment may be tossing a coin twice. And if you tossing a coin twice, the outcomes are either first one is head, second one is also head. So head and head, then head and tail, then tail and head, then tail and tail, tail and tail. So the event is 2 heads. So the possible outcomes become the sample space, and these are head, 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 tail, tail, head, and tail, tail. Now come to random variable. What is random variable? Actually, random variable assigns a real number to every possible outcomes or event in an experiment. So if you perform a certain experiment, then the possible outcomes are random. The possible outcomes are random. And that possible outcome may be we called as a random variable, because we cannot know that which outcome is come. For example, if you play Ludo, you can't know that either 1 is come, or 2 is come, or 3 is come, or 4 or 5 or 6. So random variable is always expressed by a letter X. Sometimes small x, sometimes capital X. So X is a random variable, which is nothing but a number, right? So any outcome is a random variable. For example, and you define random variable depending upon your experiment. Now, if you, for example, in this particular slide, I just take a case that number of refrigerators sold during the day. So this is a random, shopkeepers cannot, guess how many refrigerator can a particular shopkeeper sold. It may possible no refrigerator may be sold in a particular day, but this may also be this may also be the possibility that in a particular day, maybe 5 refrigerators may be sold. So if the shopkeepers have total number of 10 refrigerators, so random variable maybe come in the category of two, maybe a discrete random variable or a continuous random variable. Discrete random variable can assumes only a finite or limited set of values, and continuous random variables can assume any one of an infinite sets of value, right? So discrete random variable can have a limited or finite set of values, but in continuous random variables, and it's just an infinite set of values. Now, just we take the case of random variable as a number. So experiment is stock 50 Christmas tree. Outcome number of Christmas trees sold. So if you have a 50 Christmas tree and you want to sold these 50 Christmas tree, then number of Christmas trees sold. It is a random variable, and its range start from 0 to 50. Second is inspect 600 items. Number of acceptable items. Range is 0 to 600. Send out 5,000 sales letters. Outcomes are number of people responding to the letter, and its range from 0 to 5,000. Experiment may be build an apartment building. Outcome may be percentage of building completed after 4 months. Again, the range is from 0% to 100%. Experiment may be test the lifetime of a light bulb in minutes. Outcome, length of time the bulb lasts up to 80,000 minutes, and range is 0 to 80,000. This is the example when your random variable has not a number. So we have 3 experiments. Experiment number 1, student respond to a questionnaire. This is the experiment. You ask a question to the student, and this is the experiment. Outcomes may be student may gives answer with strongly agree one, or agree, or neutral, or disagree, or a strong disagree. So these are 5 possibilities, right? And this is again a randomness come in the picture, because you can't predict that how the student respond, particular student respond, but you know the range. It may be the case where the student strongly agree, then you assign 5, agree 4, neutral 3, disagree 2, and strongly disagree 1. So these are the following possibilities, or you may say these are your sample space, right? Second experiment, maybe one machine is inspected. When you inspect a machine, there are only 2 possibilities, either defective or not defective. So you can, the sample space is 0 and 1. 0 means defective and 1 means not defective. So your outcomes may be 0 if defective, 1 if not defective, right? Then third case, consumer respond to how they like a product. Again, your outcomes may be good, average, or poor. and you assign a number. If the consumer say good, you assign 3, average 2, and poor 1. So 1, 2, 3 are your sample space because these are the 3 possible outcomes, and you assign 1, 2, 3 according to the consumer response, either good, average, or poor. 3 if good, 2 if average, 1 if poor. So these are the example of random variable as a number or as a not number, no number. So this is all about probability and random variable, right? So students should start this particular unit by knowing this probability, definition of probability, then some terms related to probability, event, experiment, outcomes, sample space. These are the terms that students should know, along with know the concept of random variable, continuous random variable as well as discrete random variables, and should go through some example also to understand this probability and random variable, right? Thank you very much.